In the last section, you saw how we used matrices to solve systems of equations. In this section and the next one, we are going to just treat matrices like a random number, and we're going to think about how to add matrices with one another, how to multiply them, how to subtract them, things like that, basically. Okay, so we're thinking of a matrix as an object at this point, not necessarily associated with a system. We're just thinking of it as just its own thing. In the first definition, we're talking about how we can make two matrices equal. So we say that two matrices are equal to each other when every element corresponds to the same value in the other matrix. So if the 1 is equal to the 1, then this number is equal to that number, then the third number is equal to the third number, and so on and so forth. If that happens every single time for every single number, then the matrices will be basically called equal matrices. Yeah, so if the 1 here is equal to the 1 there, and the 4 is equal to 4, and so on and so forth, then it will all match and the matrix will be equal to the other matrix. So in the first problem, they're basically saying figure out what ABCs have to be so that the two matrices will be equal. Okay, so where is the A at? A is in the first row, second column. So A is in the first row, second column. So let's look in the other matrix. What's in the first row, second column? So for the two matrices to be equal, those positions have to match. Those elements have to be the same. So that tells me that A should be the number 3. Now, where's the B at? The B is in the second row, first column. So it should match the second row, first column on the other matrix. So this tells me that B should be the number -2. And finally, for C to match and for the matrices to be equal, the C has to be equal to 6. So it's pretty straightforward, not too difficult. And everything else is already matching. So the 1 on the matrix on the left matches with the 1 on the right. The 4 on the left matches with the 4 on the right. The -3 matches with the -3. So everything is good. We only needed to find A, B, C. So not terribly difficult. Okay, let's take a look at the second matrix. It's a little bit more complicated this time. So for this matrix to be equal, I need A plus B to match with C. I also want this guy to match with -3, and I want this guy to match with the 1, and finally I need the 7 to match with 7, which already matches, so no need to pay attention to the 7s. Now, by looking at the 3 things that are missing and comparing, I know that A has to be -3 automatically, and the B has to be equal to 1. There's no choice for that. Now, if A is -3 and B is 1, what would the total of A plus B look like? The total would be -3 plus 1. Okay, remember the -3 because A is -3. We found that by looking at the matrix. And why is B supposed to be 1? Because again, we found that in the matrix that B should be 1. And why am I doing A plus B? I'm doing A plus B because that's what should equal to C on the other side. So -3 plus 1 is going to be -2. So that tells me that I must pick C to be -2. Because technically, A plus B is equal to C. So the C has to match that value. Okay, so again, it's not so terribly difficult. So to find out whether two matrices are equal or not, just compare the elements in the first matrix with the elements in the second matrix and make sure that every number repeats.